This curve shows the Maxwell Boltzman distribution of molecular energies at a constant temperature in a gas at the start of a chemical reaction. On this diagram, you can see that the most probable energy at this particular temperature is given by this symbol here, EMP. So this is the most probable energy of the molecules. Let's just remind ourselves about this graph. Remember, the area under the curve represents the total number of molecules in the sample. Here, this symbol EA denotes only those molecules, so these molecules in this shaded region here are those molecules that can have successful collisions and undergo a chemical reaction. So remember, EA is the threshold temperature that energy that molecules can have before they can have a chemical reaction. You're then going to be asked the following questions. So if you're given the following changes, the number of molecules is increased at a constant temperature, the temperature is decreased without changing the number of molecules, and the third scenario is a catalyst is introduced without changing the temperature or the number of molecules. So first of all, before we even look at the next part of the question, let's see how the shape of the graph will change. First of all, if we address the first part here, changing the number of molecules at a constant temperature. So we're going to increase the number of molecules in this sample at exactly the same temperature. Well, remember that the area under the curve is the number of molecules. So let's say, for example, we increase the number of molecules in the sample. Therefore, the distribution is going to increase. The area under the curve is increasing because we've increased the number of molecules. Now, what you can see if you increase the number of molecules, let's just label that, increased number of molecules, you have not changed the temperature, so the mean probable energy of those molecules is not going to change. You can also see here that the number of molecules with energy greater than the activation energy needed for a successful collision has now increased. What happens to this curve if we decrease the temperature without changing the number of molecules? So we'll go back to the original sample of molecules, this pink area here, and we're going to decrease the temperature. Now, because we are not changing the number of molecules, the area under this curve must remain the same. So if we decrease the temperature, and we'll show that with a blue curve, what happens is the height of the curve must increase, like so. So this is at the same sample of molecules at a lower temperature. Remember, the area of the blue curve is exactly the same as the area of the pink curve. Now, if we look at the mean probable energy here, so you go to the highest part of the peak and drop down to here, you can see that the EMP at a lower temperature has decreased. It's smaller. So when it's colder,